graphing quadratic functions and analyzing the effects on its graph. So I have here an example, which is y equals the square root of x plus 1 minus 3. So we're going to identify the domain, range, opening of the parabola, vertex, axis of symmetry, x-intercept, and y-intercept. So here I have here a table below as our guide in answering the following. So to start first, for the domain of a quadratic function is the set of all real numbers. So therefore, all you have to write here on domain is set of all real numbers. And then for the range, we have here to identify the value of a. Since we're going to compare, if a is greater than 0, then this will be the formula for your range. And if a is less than 0, then your formula will be y such that y is less than or equal to k. So looking at our example, we have your y equals a here is 1. Since based on our formula for vertex form, y equals a quantity x minus h squared plus k. A is located here outside the parenthesis. So since we cannot see any number here, the value of a here is 1. Since that is positive 1, we're going to consider this condition. So then we're going to use y such that y is greater than or equal to k. So the value of k here is located here. As you can see on our formula, k is located outside the parenthesis. So here our k is negative 3. Writing the range, we're going to have y such that y is greater than or equal to negative 3. Next, for the opening of the parabola, again, we're going to identify our condition. If a is greater than 0, then it opens upward. If a is less than 0, it opens downward. A again is 1, that is greater than 0. So we're going to consider upward. So we're going to write here, opening of the parabola, upward. Next, for the vertex, the formula for the vertex is hk. So h is located inside the parenthesis. So we have here x minus h, but we have here x plus 1. So therefore, we need to get the additive inverse of 1, which is negative 1. So we're going to have here, for the vertex, h is negative 1, and then k is negative 3. Axis of symmetry. Now we have here the formula for axis of symmetry. Axis of symmetry is x equals h. So we need to change h here. So axis of symmetry, x equals, and then the value for h is negative 1. For x-intercept, to determine the x-intercept, you need to set y equals 0, then solve for x. And let's do that. So if we have here y equals x plus 1 squared minus 3, and then y is equal to 0. So we're going to have here, we're going to substitute y to 0. X plus 1 squared minus 3. Then we can have here 0 equals x squared plus 2x plus 1 minus 3. And this will give us 0 equals x squared plus 2x minus 2. Now, since this is in the standard form, we're going to apply methods in solving quadratic equations. So since this is not factorable, so I'll be using quadratic formula here. So using quadratic formula, x equals negative b plus minus square root of b squared minus 4ac all over 2a. By substitution, we're going to have here x equals negative b is positive 2, so minus negative 2 plus minus square root of 2 squared minus 4. A is 1, C is negative 2 all over 2 times A, which is 1. And then simplifying, x equals negative 2 plus minus square root of is going to be 4 plus 8. That is 12 all over 2. Now simplifying this one, we can have here x equals negative 2 plus 2 square root of 3 all over 2. And you can still have here negative 1 plus square root of 3. So this is our, sorry, I forgot, plus minus, plus minus. So this is our x-intercept. So for the x-intercept, we have x equals negative 1 plus or minus square root of 3. Next, let's erase this one. Let's go with the y-intercept. For the y-intercept, to determine it, you need to set x to 0 and then solve for y. So this time, x is equal to 0. So substituting this on our original equation, so y equals 0 plus 1 squared minus 3. Y equals this 1 squared. 1 squared is 1 minus 3. So y is equal to negative 2. So this is our y-intercept. What about if you are asked to graph this equation or this function? So to graph the function, let's have here table of values. Now to graph our example, we're going to task these values on our equation, on our function to determine the value of y. So let's start with x equals negative 3. So x equals negative 3. We're going to have your y equals negative 3 plus 1 squared minus 3. So this y equals negative 2 squared minus 3. Y equals 4 minus 3. Y equals 1. So this will be your y if x is negative 3. Then proceed with the next number. X equals negative 2. Y equals negative 2 plus 1 squared minus 3. Y equals negative 1 squared minus 3. Y equals 1 minus 3. Y equals negative 2. So that is your value here. Now continuing this process, you'll get the following values. For negative 1, this is going to be negative 3. For 0, this is negative 2. For 1, this is 1. For 2, we have 6. And for 3, you'll get 13. Then using the following values, we can now graph the following on our Cartesian plane. Alright, let us plot our coordinates. Negative 3, 1. So this negative 3, 1 here. We also have your negative 2, negative 2. Negative 2, negative 2. followed by 1, negative 1, negative 3, negative 1, negative 3, 0, negative 2, 0, negative 2, 1, 1. All right. Now, since as you can see, we have now our vertex here, which is negative 1, negative 3 at the middle, we can just use these points and then connect them. So we can have our graph. So connecting the points, of course, I need to extend this one. And there we go. Put an arrow head at the end of our line. And of course, make sure that here on the vertex, you can create a U shape. Should not have here a V shape, of course. Again, a U shape at the vertex. You need to make a smooth curve here on negative 1, negative 3. Now we have here our graph.